Hello everyone and welcome to my channel. My name is Dr. Karachi and in this video we're gonna discuss port scanning. By the end of this module, you should be able to describe port scanning and types of port scans, describe port scanning tools, explain what ping sweeps are used for, explain how shell scripting is used to automate security tasks. Now, there are different types of scanning. The first one is network scanning, port scanning, vulnerability scanning. Let's talk about network scanning. Now, network scanning, the purpose is to discover active hosts on a network, by doing network sweeping and network tracing. You know, network scanning basically is a process of identifying active hosts, like computers, servers, network devices within the network. And it can be broken down into two subcategories. Now, first one is network sweeping. It involves sending requests like ICMP echo requests to multiple IP addresses at the same time to identify responsive hosts. Network tracing, it involves mapping the logical topology of the network by identifying how devices are interconnected, which can help in understanding the network structure and layout. Now, what is the relationship to those other scans here? This is how you need to think about. Now, first of all, it can lead to port scanning. Once the active hosts are identified, the next logical step is port scanning to inspect what services are running on these hosts. Now, it can also be the foundation for the vulnerability scanning. Now, the reason behind this is that knowing the network's topology is very important for targeted vulnerability scanning, as it shows a more focused approach to identifying weaknesses. The second one is port scanning. It's basically focused on identifying open ports, like running services, and version scanning. So, like every time you have an open port, there is a service, which is an application that is currently running. So, basically, the port scanning here targets individual hosts to detect open ports, which can reveal the services running on those hosts. This involves what? Port scanning, like sending requests to different TCP or UDP ports to determine which ones respond as open. Also, version scanning, identifying the specific version of the running services, which can help in detecting outdated or potentially vulnerable software. Now, what is the relationship, port scanning? You know, basically, to the other scans, it follows the network scanning, port scanning is typically, done after network scanning, where the active hosts have already been identified. It precedes vulnerability scanning. Information gathered from the port scanning is very important for vulnerability scanning, as it helps in focusing the vulnerability assessment on specific services and versions. Now, the third one is the vulnerability scanning, identifying vulnerabilities. It could be any one of these applications. Now, the focus is what? Is that, okay, basically, it's a systematic examination of the network or system to identify known security weaknesses. Tools like Microsoft Baseline Security Analyzer, the MBSA, and Nessus are often used to automate this process. This includes, like, for example, like analyzing the configuration, you know, identifying misconfiguration, outdated software, or weak security policies. It can be used to comparing against known vulnerabilities, like checking the identified services and versions against database of known vulnerabilities. Now, what is the relationship of this to the others here? Well, vulnerability scanning builds upon the information gathered from those two here, from the network and the port scanning, allowing for a comprehensive and targeted analysis of potential weaknesses. So Basically, in conclusion, the integration of these activities supports a structured and effective network security evaluation. Basically, it provides you with valuable insights. For you, for administrator, for security professionals, and safeguarding network assets against potential cyber threat. Now, the other thing here, let's look at conducting ping sweeps. Now, ping sweeps basically identify which IP addresses belong to active hosts. It basically ping a range of IP addresses to see what type of responses is returned. And instead of sending an echo request to just one single host, you can use tools to send requests to multiple hosts across a network. Now, what is the problem with this? I mean, here you could see that it's sending to multiple hosts. The problem, it might shut down computers, or might shut down computers at the time of the sweep, which means indicates that the IP address does not belong to a live host. Many network administrators configure the nodes to not respond to ICMP echo request type 8, with an ICMP echo reply type 0. Not to mention also firewalls, may filter out ICMP traffic. Now let's look at the port scanning. Now, in port scanning, the method of finding which services are offered by a host computer, and it will help you to identify vulnerabilities as I described before. There are many, many, many tools out there. They can help you identify vulnerable open ports and launch an exploit to attack the system. Security tester must scan all ports when testing, not just the well-known ports. That's very important. The reason behind this is that there may be some open ports belong to Trojan horses. You need to find out about it. So port scanning program report the following. The first one is open ports allow access to application and can be vulnerable to attack. That's what it means. If you got closed ports, means do not allow entry or access to a service. Now, filtered ports, filtered means that a firewall filter or other network obstacle is blocking the port so that Nmap cannot tell whether it is open or closed. Let's look at this example here. This output belongs to SYN map. Now, ZenMap, it's basically a very nice in-map tool, but it uses GUI interface. And here you could see that. Here you could see the open ports here, the service, and the version number here. And of course, the port number. And this one is closed. This one is open. Okay. And it can provide you with even additional information about the operating system here, details of it here. You could see this. And here's also another screenshot. And here you could see those filter ports, the scan did not show any filter ports here. Now, filter ports, I want to talk about this, is one for which the receiving system, such as a firewall or router, has been configured to ignore or drop packets. When a port is in a filtered state, it does not respond to any request or probes sent to that port number. Now, the reasons for filtering is, one of the reasons is that there could be, security measures, like filtering specific port is a common security practice, by the way, to minimize exposure to potential threat. By not responding to a request on a specific ports, the system makes it more difficult for attackers to identify active services, but not impossible. Now, also, it could be another reason for this, the firewall rules. A firewall or other security appliance might be configured to filter specific ports. either to block known malicious traffic or to comply with, company's security policy. Compliance requirement in some regulated industries, certain ports may be filtered to meet specific compliance standard. Now with this filter? Now you might be asking, what is the impact on scanning? Well, port scanning challenges here. For individuals doing port scanning, those filter ports can pose challenges. Traditional port scanning techniques might not be able to determine whether a port is filtered or closed, as both states will not respond to probes. Now, there's a potential for misinterpretation because it may be difficult to determine whether a port is filtered, by a firewall or simply closed by the host system. Now, what advanced scanning techniques can be used? Like you could use, for example, like acknowledge scanning, like, some advanced scanning techniques such as sending TCP acknowledge packet can sometimes differentiate between filtered ports from closed ones. Now, if you receive a reset packet, you know, the port is considered unfiltered, while no responses might indicate filtered state. Now let's look at some of the tools here. Port scanning tools, there are many, many, many available, and not all of them are accurate. You know, my recommendation is that to become familiar with a variety of tools and practice often to gain proficiency and focus on on several very well-known tools which can provide you with accurate information, and do not depend on one tool only. Some of the well-known and reliable tools like Nmap, Nessus, OpenVAS, uh, especially those two are considered great tools for giving you, a very good, accurate information. Now, let's talk about Nmap. Nmap is one of the most popular port scanning tools. New features are frequently added. This is why if you have Kali Linux, you should always do update, to your Kali Linux. The GUI front, the thing that I showed you before, this is Nmap. Makes working with the complex options. This is something we will discuss it later on. Much easier for you than, typing, in the command line. The standard port scanning tool for security professionals, just type Nmap and the IP address and it can scans every port on the computer based or specific ports based on your settings. Now, this is example of Nmap help screen. It's very important for you to become familiar. You just type, man Nmap, and you could learn a lot about it. There's a target specification, host discovery, scan techniques. All these are very important for you to understand. Now, let's take a deep look into Nmap. Nmap is a powerful network exploration tool and security port scanner tool that performs the task of a network mapper and can show running services on the Windows. It's available in Kali. ZenMap, it's a GUI version, and it works on multiple platforms like Linux, Windows, Mac OS, and others. Now, the command line syntax is like this: Nmap, scan types, okay, like any one of these types, and we're gonna discuss it. The options, like for example, if you want to, input from a list, for example, you use this switch over here, and the target specification can be IP, hostname, network, or even a domain name. Now, how to access Nmap? You start your Kali Linux, you click on applications, and then, okay, and then you will find it under you know recently actually like favorites or recently used or whatever. So you could find it here, right, in this section over here. Now, let's look at Nmap without any options, by the way. It scans 1,000 ports on a target. Now, it's very important for you to understand the Nmap states. The first one, open, means an application is actively accepting connections. If it's closed, mean the closed port is accessible. It receives and responds to Nmap packets, but there is no application running or listening on it. Now, filter means Nmap cannot determine if the port is open because of the packet filtering, such as firewall. Unfiltered means the port is accessible, but Nmap is unable to determine whether it is open or closed. Open filtered, Nmap unable to determine whether a port is open or filtered. Open ports may not respond. Closed filtered, Nmap is unable to determine whether a port is closed or filtered. Now, what we're going to do here, we're going to start looking at famous, well-known types of scans for Nmap. The first one is the Connect Scan, -S, capital letter T. What does it mean, Connect Scan? It completes three-way handshake. Same when your operating system tries to establish a connection with the target machine and port by issuing the connect system call. Now, basically, the connect scan is a straightforward scanning techniques that uses the system called connect to establish a connection to every port on the target. Now, if the connection is successful, the port is determined to be open. If the connection fails, further analysis is required to determine whether the port is closed or filtered. Now, here you could see from the scan, here we could see that the port number, the state open, and here is the services. You can see that it is, it shows you the name of the service associated. Now, let's look at the operating principles. Okay, so here we could see that this is open ports. I mean, it means that when a connection request is sent to an open port, the target system acknowledges the request and the connection is established. So that's why Nmap marks the port as open here. Now, in some cases, if you see instead of open, closed, means the port is closed, the target system will send a TCP reset packet. Nmap marks the port as closed because it's received reset. If it's filtered ports, if there is a firewall or any filtering device in place, the connection attempt might be dropped altogether without any responses. In this case, Nmap may mark the port as filter. So, what is the drawbacks for Connect Scan? Well, it's a slow because the process of fully establishing and tearing down connections can be slower than other scanning techniques like the SYN scan. We're going to talk about it. And it's easily logged because of the type of connection, the firewalls, other system will easily log this type of scan. Now, SYN scan, it can be performed quickly, scanning thousands of ports per second on a fast network not troubled by intrusive firewalls. It's stealthy since it never completes the TCP connection. Now, others, they might call the SYN scan, half open because it does not complete the standard TCP three-way handshake. Instead, it initiates the handshake and then aborts the process. Try to avoid scanning. Now, what is the operating principle? Like sending SYN packet okay, which is, just make sure you remember that this is part of the TCP flags in the TCP header. Okay, sending a SYN packet, the scanner sends a TCP synchronized packet to the target port. Now, open ports, like you see here, okay, if the port is open, the target system will respond with the SYN acknowledge, okay, synchronized dash acknowledgement packet. Now, instead of open, you see closed, okay, the target system will respond with a reset packet. Now, filtered port, okay, if there's a firewall there, no response might be received and the port may be marked as filtered. Now, the benefit is what? Stealthy. Since the connection is never fully established, it is less likely to be logged by, conventional logging system. However, some IDSs, advanced one, are capable of detecting SYN scans. Now it's efficient. Why? Well, it's generally faster than a full Connect scan, as it does not wait to establish the complete connection. I think we discussed it before. Now let's look at another type of scan. Null scan. Here we have, the dash SN. Again, those are the flags found inside the TCP header. Okay, does not set any bits. So the TCP flag header is zero. So everything is zeros. Now the finish scan, okay, it's in the finish. Sorry, it set just the TCP finish bit. The Xmas Scan, okay, sets the finish push urgent flags, basically, like what they're saying, lighting the packet up like a Christmas tree. Now, these three scan types are exactly the same in behavior, except for the TCP flag set in a probe packets. They can sneak through a certain non-stateful firewall and packet filtering routers, are more stealthy than even a SYN scan, but most modern IDS products can be configured to detect them. Now let's look at the Nmap, those type of scans, how they react. Now, if you see in the output, open filtered means no response received, even after retransmissions. Now, if you see closed, means TCP reset packet received. Now, if you see filtered, it means that you're going to receive ICMP unreachable error type 3 code can be any one of these here. So what is the downside of this? The big downside is that not all systems follow the RFC 793, which is basically the transmission control protocol, DARPA Internet Program Protocol specification for the TCP to the letter. See, a number of systems send a reset response to the probes regardless of whether the port is open or not. This causes all of the ports to be labeled closed, such as Windows, Cisco, or even IBM. Okay. Now this type of scans do work against most Unix-based systems. Now, there's another downside of these scans is that they cannot distinguish open ports from certain filtered ones. If the packet filter sends an ICMP destination prohibited error, Nmap knows that this port is filtered. Now, since Nmap cannot be sure which is the case, it marks non-responsive ports as open filter. Now, I think it's very important to add version detection, which is something we will discuss it later, can remove uncertainty as it does with UDP scans, but that defeats much of the stealthy nature of this scan. Now let's look at this example here. The dash S capital letter V for version scan, uh, you can see that, we're using nmap dash SX for Christmas scan dash SV, the IP address. And right now we're able to see more output. Here you can see those are open ports, and we know the service name, and here we have the version information. The thing about the version scan flag is used to determine the service version. It enables Nmap's version detection, which can query various services running on the target's open ports to determine more detail about the specific version of the running software. This information, it's very useful, okay, in assessing potential vulnerabilities or understanding more about the target network. Now let's look at some of the output and pay attention to the screen over here. The first one is the null scan. You see that? You see the output right here and those open filtered, okay? And here for the finish scan, open filter, okay? And here for the Christmas scan, open filter. And if you notice, the output is basically the same, okay? Now, another important scan is called the acknowledge scan. Now, this acknowledge scan is used to get past firewall. It never determines open or even open filter. So the output will look like this. It is used to map out firewall rule sets, determining whether they are stateful or not, and which ports are filtered. When scanning unfiltered systems, open and close ports will both return a reset packet. Now, Nmap then label them as unfiltered, meaning that they are reachable by acknowledged packet, but whether they are open or closed is undetermined. Ports that do not respond or send certain ICMP error messages back are labeled filter, as you see right here. ICMP, this is filter. No response received even after retransmission is filter. TCP reset response is unfiltered. Now let's look at the UDP scan. Now, Uh, this is another important type of scan. The UDP will look like this, -SU. UDP scan works by sending a UDP packet to every targeted port. For most ports, this packet will be empty, no payload. But for a few of the more common ports, protocol-specific payload will be sent. And here you can see that in map-su, and here's the IP address, not showing the closed port, and the open port showing open filtered, and the service information. Now let's talk about a very important scan option with Nmap. It's called Operating System Detection -O using TCP stack fingerprinting. Let's focus on fingerprinting. Now, let me show you the output here. See Nmap-O, the IP address, and of course it will display the ports, the status of the ports, the services. And here you could see that, it's showing you the type of operating system details. It says Microsoft Windows 2000 SP0 or SP4, or maybe Windows XP SP0 to SP1. Now, what is OS fingerprinting? OS fingerprinting is a process of determining the operating system used by a host on a network. The goal is to give you the best guess about the host role. Okay. Now, you could add like -- OS scan -guess after the dash O here, as you see it in this example here. Now, this makes Nmap guess more aggressively. So combining those two together make it more likely for Nmap to make an educated guess, even when the available data is insufficient for a definitive identification. I mean, this could be useful when the fingerprint does not precisely match any known fingerprints in Nmap's database. Now, to make a determination about the operating system, keep in mind that Nmap has a database of fingerprints. The fingerprints contain details about how each operating system behaves, including how the IP identification field is generated, the initial sequence number, the initial window size, and other, several details. Now, to identify the operating system, Nmap has to find at least one open port and one closed port. Now, one thing to keep in mind when you do an operating system scan is that Nmap relies on fingerprints. And unlike people, the same fingerprint can match multiple operating systems. Like, for example, like in case of Linux, the same kind or the same kernel may be used across multiple distributions. But since the only thing being identified is the kernel, there is no way to know what distribution. Like, and for example, Nmap cannot tell you if this is Ubuntu or Debian or what. Okay, if they're using the same kernel. This is just an example. Now, let's go over some another scan options. The first one is port specification, Nmap-P80. That's if you want to scan single port. And if you want to scan like port 21, remove 80, type 21. Okay, any port you want to scan, you just have to type -P, the port number. Now, if you want to do port range scanning, simply type -P from which port to which port. Or if you want to do deep scan, you could type from 0 up to 65,535, which is the total number of ports for every IP. Now, if you want to save the results into a file output, just type -on output, dash file, or you could, just remove that, or you could type whatever file name you want against the IP address. Now, here we have another example, Nmap-SN. This is for host discovery. It basically skip port scan. That's for a quick host discovery. Now, if you want no ping, Nmap-PN, and then, I mean, basically, there's no host discovery. Okay. It's basically probe each host, assuming they are up. Now, you have less scan. Now, just what is less scan, by the way? It's unlike most other Nmap scan. The primary purpose of this option here is not to detect live host or open ports or even services, but rather to enumerate all the IP addresses in a specific range without actually sending probes to the target host. I mean, this makes it a non-intrusive way of simply listing the targets in a given range here. Now, let me talk about banner grabbing and, basically what is banner grabbing, before we talk about also the countermeasures. Banner grabbing is an enumeration technique used to collect information about the computer system on a network and services running on specific open ports. It is a valuable reconnaissance step for attackers seeking vulnerabilities in a target system. Now, here you could see that you could use either one of these options here, -SV for version detection, --open, looking only for open ports, and -operating system, as we discussed both before. And here you could see this is the banner. Okay. That's banner information. Now there are many countermeasures, you could do. Basically, I want to get into much more details about the countermeasures. The countermeasures can be divided into network level measures or application level measures, monitor and logging, and advanced countermeasures. Let's talk about the network level measures. For example, you could use the firewall configuration to block or limit access to certain ports. Can effectively, stop banner grabbing attempts or, make it much more difficult in this case. Now, you could use intrusion detection or, or IPS, intrusion prevention system. Deploying both of them can help in detecting suspicious activities like multiple requests to a service. So therefore you can be alerted, you or it can block the incoming IP address. That's in case of intrusion prevention system. It can block and detect. IDS, it can detect only, but it does not block. Now, what about application level measures? You could do customization of banners. This is one of the straightforward methods is to modify or customize the service banner. Now, service banners should be generic and free of any information about the software version or other specifics, which could aid attackers in their reconnaissance. You could do also like a protocol level decoys, by implementing fake banners or responses for unauthorized users can serve as a disinformation, thereby confusing attackers and making it harder for them to learn the truth of the system. Now, there's another option, like I said, monitoring and logging. Comprehensive logging, ensure that logs are properly configured to catch unauthorized access attempts or information gathering attempts like banner grabbing. Regular audits, routine scanning on audits of logs to detect any anomalies. I mean, you could use like a system like SIM, Security Information and Event Management Solution for this. Now, last but not least, advanced countermeasures like honeypots. Deploying honeypots can divert attackers away from legitimate systems. The honeypot can be configured to display false banners, in order to confuse the attackers. You could also use behavioral analytics. Machine learning algorithms can be deployed to understand normal behavior and flag any activities deviating from this normal, you know. Now, I have provided you basically with an overview of Nmap and scanning options. Now, you could turn to my other videos here on my YouTube channel and basically try to practice Nmap. Here I have several Nmap videos for Nmap scan techniques, Nmap service and OS detection, port scanning, host discovery, scripting for, it's just a beginner guide. You could learn and practice those options, after this particular lecture. So what we've done so far, what we learned is that, we scan the network to look for live hosts. Next step, after we identify, live hosts on the network, we try to discover, ports and services available. So what's next? Well, the next thing right now, it's time for vulnerability detection. Now, vulnerability detection is identifying security weakness in the software, hardware, or networking components that can be exploited to compromise the integrity, confidentiality, or availability of the information system. So what is the goal? The goal is to discover these vulnerabilities before they can be exploited by malicious actors, enabling proactive, fixing to enhance an organization's security position. Some, not necessarily all, of the discover services may be vulnerable. So, fingerprint these discover services to obtain additional information, such as version, and you use this information to discover any vulnerabilities, as we discussed it before. Now, what are the components of vulnerability detection? The first one is asset identification. So we could see that by the scanning, and before the vulnerability detection can occur, we must create a comprehensive list of the assets, such as servers, network devices, databases, and application must be prepared. Now, there are different type of scan. The first one is the static analysis, known as a static application security testing. This involves scanning the source code, bytecode, or binary code, of the application without executing it. There is also a dynamic analysis involved in vulnerability detection, which is it's known as dynamic application security testing. This involves scanning application during runtime to identify vulnerabilities. Now we have also network scan against firewall, routers, switches to identify potential vulnerabilities. Okay, so what scanning tools there? There are different scanning tools like Nessus, OpenVAS, for network vulnerabilities, and you got other scanners for application vulnerabilities like check marks, and many, many, many more. Configuration review. Vulnerability often exists due to misconfigured services or permissions or security settings. The configuration review under vulnerability detection can help you identify such weakness. Now, what about database scan? There are specialized tools can be deployed to scan database or vulnerabilities such as, SQL injection or insecure storage practices. Also, we have patch management. One of the most effective ways to identify vulnerabilities is to compare the current versions of all software and firmware against the latest patches and updates provided by vendors. And there's a lot of good application that will help you to do the patching. So, what vulnerability methodology are used? I mean, the first one is the automated scanning. Basically, you are utilizing software tools to automatically identify vulnerabilities. They're generally faster, but may result in false positive or negatives. The other one is the manual testing here. That's performed by human expert, called pen testers. They often following guidelines, for example, like OWASP testing guide for or the pen testing execution standard. Manual testing is usually more accurate, but are more time consuming and expensive. Now, my favorite part is to do hybrid approach, which, you could combine both. I mean, you could start by doing, in my opinion, automated scanning, fix whatever it was discovered by the software. Then you could hire a pen tester to do the testing to discover things that was not discovered by the application using automated scanning. Now, let's look at the vulnerability databases, where to see them, where to find them. I mean, obviously, the next part right now, after you discover those vulnerabilities, using tools, which I will show you later on, is to research and discover services using vulnerability database, such as CVE details. CVE stand for Common Vulnerabilities and Exposures, which is a publicly available database that provides standardized identifiers for publicly known vulnerabilities. And so CVE is basically a list of entries, each containing an identification number, a description, and at least one public reference from publicly known vulnerability, cybersecurity vulnerability. And there's also another source, very well known, National Vulnerability Database, NVD, which is a USA government repository of standards-based vulnerability information, and here's the link. And here's the CVE details, and here's the link, and here's just an example, of the vulnerability discovered, and with some information, the dates, and ranking, and so on. So right now we learned that the attacker discovers certain vulnerabilities. I mean, so after attacker learns about them, what's next? I mean, they will do initial exploitation. The attacker tests the exploit on a target system. This can be as simple as entering malicious SQL queries into a web form, or as complex as executing a series of operations that can take advantage, for example, like buffer overflow vulnerabilities. Hackers might, employ evasion techniques to avoid detection. Different techniques are out there. They might do privilege escalation. Upon successful initial entry, the attacker may have limited access rights, so the attackers often attempt to escalate their privileges to gain more control over the system. Techniques for this can include exploiting insecure service configuration or using non-privilege escalation exploit. The attacker might also do data exfiltration. I mean, the main objective involves stealing data. The attacker will identify important data and create a strategy to remove it from the target network or a computer. Some hackers would love to maintain access. Why? Well, to maintain long-term access to the compromised system. Attackers may install backdoors, rootkits, and other types of malicious software. Now, finally, if the task is finished, it's time for cleanup. You know, some savvy attackers often erase logs, disable monitoring tools, or take other actions to remove evidence of their activities. Now, there are many, many different vulnerability scanning tools. Like for example, like here we have Nessus. It's a vulnerable assessment tool from Tenable. It has much more capabilities than Nmap by analyzing open ports for specific version information, much, much more details as well also, and very clean output. It provides detailed vulnerability information on corresponding service. There are Essential, which is a free version. You can download it and play with it and use it, and just, and to learn about important features. But the professional will give you much more options. Here we have the OpenVAS, now branded as a green one security assistant, capable of updating security check plugins when they become available. So that's one option. You could learn about it. Now, if you look into my YouTube channel under vulnerability scanning playlist, you will find many videos related to the topics I just discussed. For example, here we have Nessus using advanced scanning. Here we have Nessus vulnerability scanning, host discovery, Nessus web application test. So I basically go into details how about the features, how to configure it, and how to do it. And here you have also OpenVAS vulnerability scanner and Nikto, which is another well-known web vulnerability is scanning. Okay, so now let's learn about other tools that can be used to ping, multiple IP addresses or even single IP address. For example, like fping tool, you could ping multiple IP addresses at the same time, which is included into Kali Linux. It accepts a range of IP addresses. You can enter it at the command prompt. You can create a file containing multiple IP addresses. You could use it as an input for the ping command, like from the file. Now, the input file usually created with the shell scripting language, so that you do not need to type thousands of IP addresses needed for a ping sweep. And now simply if you type man fping, you'll be able to see all other options here that you could use with fping. For example, dash h, print this help, dash capital letter A, show targets by address, dash D, use DNS to look up addresses of return ping. So to ping sweep a range of IP addresses without using an input file, you use this command, fping-g, beginning IP address, ending IP address. The dash G parameter is used when no input file is available. And here is just a simple example you could do, fping-g, here's the IP and here's the IP, and the command returns the result shown in the next figure I'm going to show you shortly. Another option you could use with fping-c parameter, fping-c2 mean that's the number of pings. Now, here's just an example, you're doing from here to here, and there's also another example result of fping command showing you that this is, this IP is alive, and others are ICMP host unreachable for different reasons mentioned before. Now, let's look at HPing3. Now, HPing used to perform ping sweeps. It can bypass filtering devices, which and also it allows you to inject modify IP packets. It's very advanced port scanning tool, by the way, and many security tester use it, and you must be familiar with this tool. And it's available in Kali Linux, and it works, and this is the command syntax, hping3 host options, whatever option, which is we're going to discuss it now. Now, by default, hping3 uses TCP with no flags set. You can change the mode using the following thing, like for example, -0 raw IP mode, -1 ICMP mode, -2 UDP mode, -8 scan mode, -9 listen mode. Okay, just make sure you type sudo -r or log in as a root, from the beginning to use hping3 in Kali Linux. Now, also another option, you could set a flag in hping3. Simply, you could specify it as an option. And here, these are the flags. Pay attention to the difference between the flags written for hping3 versus nmap. Like for nmap dash small, small letter S, capital letter S. In hping3 dash capital letter S for sync, dash A for acknowledge. And here is basically, this is how you type it. The command -s and the target IP. Now, let's look at HPing port specification. By default, HPing3 uses sends packet by default to port 0 destination. That's the default one from randomly dynamic port source. However, you have an option to specify the source by typing -s option right here. And by the way, do not confuse -s, the small s with the capital S. Capital S for send, small s for source, And then also you could specify the destination with the -p option. Look at this example here. hping3, the IP, dash capital letter S, we're using SYN Scan, and dash small s from this port, okay, and to, for example, like any port you specify that you want to scan, so here basically, so the scan will originate from this port against this port. Now, here's also another examples here. Now, hping3 -8, okay, which is basically the scan mode right here, and that's the port ranges. So I'm asking hping3 to scan from port 20 to port 25, and we use capital letter verbose for more detailed information. Now, how HPing will react, we use this, TCP scan with no flags set, okay, if you don't set any flags, okay, like here I set flags, close port respond with reset, acknowledge. Open ports will not respond. Now, in this example here, I'm using the IP, I'm using the SYN flag. It's already set with the scan mode, because I want to do scanning for these ports, verbose, and here you could see that, reset acknowledge. This means what? The FTP dash data port 20, okay, is closed. You see that? Here's the output. Close port, respond with the reset acknowledge. Now, for SYN acknowledge, now, okay, here's the open ports will respond with these flags set. Okay, so that's how the output can be seen. Now, there's also useful HPing 3 probes listen mode. Now, -9 listen mode. Here, if you want to intercept HTTP traffic and you want it to listen on this interface, like either 0 or 1 or 2, whatever. And the result of this, you want it to be saved in output file. I mean, if you want to test it, you could test this command. Just open web browser and visit any website, and then take a look at the output in the generated file you created right here. Now, there's also another option if you want, useful, but of course, do not do it for doing, DOS attack. HPing, and here's the target, and you want to send, see the dash is for the count, 10,000 packets, the size of each packet dash D 120. You want to do a SYN scan, and here you want to set the TCP header window size to 64, and you're targeting this particular port, and then you have to add the flood mode for the DOS attack, and you want it this coming from a random port. Basically, you could test this command simply, turn on metasploitable virtual machine with FTP servers and try to test it, and and if you get, and yeah, I mean, you will eventually have non-responsive FTP because it's being flooded with a lot of packets and the service cannot handle any requests. Now, another interesting topic, it's about crafting IP address. The idea here is to try to simulate an attack to identify the properties of a network. They are commonly used to invade firewalls and intrusion detection software. Packet components, can be like, the source IP address, destination IP address, and the flags. It helps to obtain information about the service. There are many tools like this tool, called a soft packet builder, enables creating custom network packet, and you could basically go inside the protocol field and edit those field values. I mean, so what is the idea behind crafting IP packet? I mean, think about it. It's a manual creation and manipulation of IP packets. So in this context, crafting means building a packet with a precise control over the various fields and flags in the IP and higher level protocol headers, like TCP, UDP, ICMP, etc. This practice can be useful for various purposes in network analysis, security testing, and research. Now, here's, for example, look at the fragment flags, and this is the Soft Packet Builder. Here you have the fragment 1, okay, and here we have protocol 6, okay. So anyway, what I do, basically, I went there and I changed the protocol to 90, which refer to something else, and I changed the fragment to 0. And you could basically go inside each one of them and do whatever modification you want to do. And that's what we call by crafting IP packet. You know, okay. So it's also beside use for security testing, network diagnostics, or research and development, it also can be used to simulate an attack scenario. You know, basically, it will help you to understand potential attack vectors in a controlled and in ethical manner. So keep that in mind. Now let's look at the last topic, which is understanding scripting. Some tools might need to be modified to better suit your needs as a security tester. There are many customized, I mean, there are many, programming languages help you customize the script. Why? Well, for automates task, time saving, but it requires basic programming skills. I mean, also can give you with the flexibility because scripts can be customized to perform very specific function tailored to your needs. And, and basically, it has those scripting languages are generally more forgiving and flexible, enabling rapid development and prototyping, Now, it's similar to DOS batch programming, a script or a batch file. It can be a text file, okay, that contains multiple commands that are usually entered manually at the command prompt. If you find that you are using repetitive commands to perform the same task, that task is a good candidate for scripting. Now, the best way to learn how to create a script, you know, learn how to create that. There are, by the way, different type of scripting. There's a shell scripting, writing scripts for command line, a command line shell like Bash, PowerShell. These scripts can automate system tasks or manage files or create series of commands. Now, there's also web scripting, writing like client-side or server-side scripts that are executed within a web browser or web server. Languages like JavaScript, PHP, Python are often used in web scripting. There's also application scripting, you write scripts to automate tasks within a specific software application like Excel, and some other application also can be done. Now, this is a shell script with commands. And finally, this is the summary. Now we learn about describe port scanning and types of port scans. We learn about port scanning tools, ping sweeps, and crafting IPs. And finally, briefly, we talked about shell scripting. Finally, thank you so much for watching this video. I hope you found it useful. Please make sure to click the like button. Thank you again.